In this video, we're going to look at Swift intermediate representation inside of the Kotlin compiler. SIR is part of the tool for doing Kotlin to Swift translations. It's something that's in the work, it's in progress. It's part of the Kotlin to Swift export tool. There are several things to know before we get started. First, this is not a general purpose tool. It also does not have all Swift declarations yet. What we're going to look at in this video are examples of Swift source and how it's represented using SIR and what are the different APIs available to us to build SIR. So here's a very simple example of a function in Swift named foo, and it returns a boolean. How is this represented with SIR? So there's a pattern that's followed with SIR tree. The root node of an SIR tree is a Swift module that you could give it a name, you could add decorations to this. This is the scaffolding for an SIR tree. The SIR module underneath the hood takes in the name of it. It also takes in any decorations that you have, such as functions or classes. It also takes in imports. There's a DSL provided for us to build this. And what it does is that internally it builds a concrete type of an SIR module. So let's build our Swift module first. To build a Swift module, the minimum that we need is the name of it. We'd also need to add decorations to it. In this example, we're going to add a very simple function decoration to it. So let's build a module using its DSL. There's a DSL provided for each type of SIR element. So to build our module, we're going to give it a simple name, just like this. And now we're going to add a decoration to it. In our example, we need to build a child node of our Swift module, and it's represented using this type called SIR function. An SIR function gets created by adding a decoration to this module. So we could add decorations to this as many as we want. So let's build a function. In order to build a function, the build function DSL is provided to us, and it takes in the name of the function. It will take in the visibility of the function and also the return type of it in any function body. So in this case, the visibility is represented by an enum, which is in this case public. We also need to specify the type of function this is. So this function is a simple function type, but you could also have static methods, class methods, instance methods. We'll look at instance methods later on. So we could specify the type of callable this is by using this enum class. Then we need to specify the return type, and the module provides us with different types of return types that we could use. And what it is underneath the hood, this module contains structs for us for these different types, bool, int, double, or float, that we could reuse. So in this case, I have built a very simple example of an SIR function as part of this module. So when you take a step back and you look at the SIR tree that we have just created, it looks like this. It's very simple and it's flat. In this case, at the root, we have our module. The module is always the root, and the child node is an SIR function. It could be a class if we want. It could be something else. This is the simplest SIR tree. Now let's look at how to do a little bit more complicated things, such as building a class with a function. Here's a very simple example of a function, of a class with a function in Swift. We have a class called foo, and it has a function called bar, which takes in one argument or returns a boolean. How do we represent the SIR tree for this? So similarly, we're going to start with our root node, which is going to be our module, and it's going to have a decoration, which is going to be an SIR class. So let's build this out. So to build this out, what we're going to do is that we're going to start off with our module. We're going to give it a name of it, which is class with function. And I'm going to start to add in decorations to this. So the first decoration that I'm going to add in there will be a class. So in order to build a class, we have a DSL for this. And we're going to specify the name of the class, which is foo. And then this class itself has decorations, which could be like members of the class or functions of it. So in this case, we need to add in declarations. In our example, we have a very simple function which takes in an argument and returns a bool. In order to do this, we're going to follow the same exact pattern as we did before. We're going to build an SIR function type. So in order to do this, we're going to build a function. We're going to give it the name of the function. And in this case, the type of function this is, the callable kind, is an instance method. It's not a function. It's an instance method. And we're also going to specify the return type of this. So this, as we saw earlier, we have an enum that allows us to use different types of callable kinds. In this case, it was an instance method. In the previous example, was a simple function. Then we're going to specify our visibility, and then we have a return type. So far what we have done is built out this tree. It looks like this. We have our root Swift module, which is part of the scaffolding, and we have a single child node, which is a SIR class. And this SIR class also has a child, which is going to be our function. Now there could be n number of child nodes there. You could have number of SIR functions there as you want. So even though this is a very simple flat hierarchy, it could get nested depending on how the complexity of your class, complexity of your source. So in order to be able, how do you go about now adding in arguments to a function? So we built out the function named bar, and it was a public function, and it needs to take in an argument, and there is an SIR type for that. And what we need to do is to add in parameters, and we could add in a list of parameters as we want, just like this. And we're going to use our SIR parameter, just like that. In this case, look, if you see this, I'm not using a DSL function for it. I'm using the raw SIR parameter type, and I'm giving it the name of the parameter, and I'm specifying what type this is. Keep in mind the way that I'm specifying the bool. Just as I did before, I'm grabbing it from my Swift module, my built-in structs that I could use for my types. So this is how you add an argument to our SIR tree. And what does the SIR tree look like when we have done this for this simple example? So at the root node, we have our Swift module, which has a child node, which is our SIR class, which has a function, and the function itself has one parameter in this case, but it could have n number of parameters. So even though this is a flat hierarchy, it could be nested, and this is what our SIR tree looks like. Now let's look at a little bit more of a complex example. Swift also has extensions. How do we represent an extension like this for a type in 32? So this is Swift code. How do we represent the IR for it? So if you were to build out the IR, first we're going to start off with our module, just as we always do. We're going to add in a declaration, and there's a build extension DSL, which is provided to us. And what it allows us to specify is our extension type. What is the type that we're extending? In this case is an N32. So this is a very simple example of building an extension, and to build out this extension and what it's going to have in its body, you could add in more declarations as you want. That's going to build out your SIR tree. So in the end, this is the SIR tree for building out this extension. So let's take a step back and understand this SIR elements more. So far we looked at examples like this, which is a class with a function, and we built out the SIR tree for it. Underneath the hood in the compiler, each node in this SIR tree is an element type, and it follows a hierarchy that you could look at. So let's look at an example of an SIR node, something that we haven't looked at, which is an SIR variable. So if you're trying to represent like a Swift source for a variable, you would use this element. And all elements, whether it's a class or function, they all inherit a root interface, a root element, root sealed interface, which is an SIR element. And then what you'll see is that there's a hierarchy which goes down from the top to the bottom. This, as you can see, I have an element base type right here. And then I have my SIR variable type inheriting that. So you can see that there's a hierarchy from the top to the bottom, and all element types follow this hierarchy in an SIR tree. Inside of the Kotlin compiler, you could get an idea of all the elements that are in there by looking at the Swift tree. So this is in the part of the Kotlin compiler, this Swift tree, Swift IR tree, and you can see there we have our root element right there, and we also have other declarations, other elements that are part of this. You have an enum, a module, a function, everything that we just looked at. In the Kotlin compiler, what you could do is that you could generate a tree from this. You will generate all the builders for each of the elements. What it does underneath the hood is that it takes a module element like this, and it generates a type for that, an abstract class. In this case, it also generates the implementation of it. So as you can see from the comments there, this is generated from that element type of a module. So the Swift IR tree is very, very useful to look at the hierarchy of things. In the next videos, what we're going to look at is that we're going to build upon this. So we're going to look at internally how the Kotlin Swift tool works, how it leverages this. So we're going to look at how from the Kotlin source you could go to Swift, you could export to Swift. And in order to do that, there's a middleware that you need, which are something called bridges. So what you could do is that you can make a request to generate bridges, and you could utilize those bridges to go to your Swift source. And we'll look at underneath the hood how that works in the next video. I hope that was helpful to you.